Good morning, Ignite students. Here we go. It is time for an astronomy day. Everybody's having a good day, so let's get started. We've got a few things to talk about today, and it's time to go, go, go. First, most important thing to know, the universe is big. Big. It's huge. And we're going to do astronomy, and we can't cover it all, but we're going to cover all of it. All right? First thing, I know it says 1977. None of you were born then. That's fine. Guess what? It's old. It's still good. IBM made this video. It's really awesome. It shows you how big the universe is. How big the universe is. The way it zooms out. Watch the math on here. These exponents and then the short scale numbering, what it's doing, it's zooming out so that each frame is 10 times bigger than the previous one. So as you go out, you're actually speeding up because you're doing 10 times further. It's kind of interesting to see what it's doing, and then it zooms all the way back in, and you get to see some little bitty stuff. But the universe is big. There's one way to see how big it is. Way two, right here, we're going to zoom out a little bit, and we're going to find, too far. Let's try that again. Those are lots of stars. These are all sorts of other stars. Let's just start while I'm out here. Right here is Betelgeuse. There's one. Don't say it again twice. Betelgeuse is a large star. It's the shoulder of Orion in the southern hemisphere. As you zoom in, it is a huge red object. You'll see all these other stars, blue, red, hot, all sorts of different things. And we zoom in and we don't see our sun yet. Our sun right here is that size compared to the others. This does not show you where things are. It shows you the scale between the things, okay? Which is kind of interesting. It is a great companion. Both of these things are going to be linked on Canvas. You can zoom way out. You can zoom way in. Inside of our sun, we can zoom in a little bit. Now we get planets, Jupiter and Saturn, other stars nearby. Proxima Centauri is the closest star to us. All right, Sirius B, that's the dog star. It's a very bright star in the evening sky. Now you've got planets. You've got the 4 Galilean moons, Io, Europa, Ganymede, and Callisto. Compared to Earth, Venus, and Mars, you can see the relative size of all these. Mercury's in there, is a little bitty guy. Titan is a moon of Saturn. Triton is a moon out there. These all sorts of stuff in there, and you can zoom in, you can zoom out, you could see what's going on. Countries, states, all the way in. Moons, Phobos and Deimos, are moons of Mars. If you want, they're really kind of comets or asteroids. We'll talk about that later. But this, you could keep going in until we get to, let's just get down to us, because, we're self-centered like that. There we are. There's a human. And then it goes on in and it goes on out. Interesting stuff to do. All right. Those are 2 links you're going to see on Canvas. Here's the new one that's going to be on there. OpenStax. Up here, OpenStax with an X right there in the URL is a really good resource, okay? You may not have a big note page. You might not have everything, but you need a book. You need an online book. This is it. OpenStax has free, really high-quality books for college level, freshman biology, freshman chemistry, freshman math, college algebra, calculus, all of these things. And then they've started adding and expanding. They've got some AP additions to this and that. And this is going to be an astronomy book, which is going to be a good reference for us to every now and then. It's not going to work when we get to rocks and minerals, but for astronomy, it's going to be awesome. Here we go. This is a different way to put it. This is not to scale. This is not to distance, but the size of each planet. You could see how similar Venus, Earth, and Mars are.
The following students need to come to the office. Gavin
Pause.
Read.
Hey, we're back. Here we go. This is the relative size of everything going on in our solar system. This is the relative scale and distance between Earth and the moon. Pretty picture of Earth. All sorts of other good things going on here. Some history, some size. Very cool stuff. All right, 2.1. Chapter 2, Section 1. If you start looking in the online book, there's all sorts of stuff. What do things actually look like when you go outside and look up? Well, anymore they look bright, right? There's a lot of stuff going on. There are lights everywhere, and it's tough to see, even though we live in a part of the country that's not that dense and populated and overlit, okay? Zenith means straight up. We're going to get some more vocabulary terms. So the horizon is flat out around. Here you are. If you're somewhere in central North America, zenith straight up for you is not where the North Pole points. Your horizon is this out here. That's flat to you. North is that way, which is why that the North Star, one of the hooks on the Small Dipper, does not look straight up. It's not up. It's out there. And as the Earth spins, it's still out there. And as this goes around the sun, it's still out there. Okay? This is essentially the celestial sphere. Okay? So why do things look like that? Because that's north. And so if you put a camera on long time lapse, you can get that star to streak across the sky because the Earth is turning. All right? Here we go. Same thing. Just imagine if you stood on the North Pole, your zenith is there. If you stood on the equator, right? You stood on the equator, your zenith is there. Here we go. That's where we're at. This is the ecliptic. Okay? So as Earth goes around the sun, the apparent path the sun traces on the sky is the ecliptic. All right? So constellations, that's all fine. Here we go. If we were to track and put the Earth in the middle, old school, it's wrong. This is not correct, but it's useful because we can now say, hey, this red line here is the ecliptic. It's the path the sun traces across the sky. So March, June, September, and December. Speaking of, September 22nd, right here, the sun is going to cross. See, the sun is in down here at June. It's going to come up. Sorry. We're facing this way. The sun, we're seeing it above. The sun is going to go around because this one's drawn with the Earth is a tilt. And it's going to dip below our equator. This dotted line here represents the equator of Earth, and it's going to get lower in the sky. We're going to head towards winter. So this is the autumnal equinox or the fall equinox. So over here, then we've got the spring equinox. Then you have the summer solstice over here and the winter solstice. This is when the sun is highest in the sky. This is when the sun is lowest in the sky. Here and here, equinox, equal day and night, 12 hours and 12 hours. Okay, September 22nd. There's not a magic thing that happens. The sun is just going along this path, or really the sun doesn't go along this path. The sun is in the middle and Earth moves along the path and Earth crosses a line. And crossing that line is when the equinox is. We call it the full day. It's actually just a quick second as we cross the path. Okay? Fixed stars, constellations. Constellations, they're old pictures. Hey, there's that Betelgeuse again. All right, there's Orion. You'll see it. It's a big prominent thing in this winter sky in the south. We'll talk about that. Some other things we need to talk about, though, this. So let's look here. We need to talk about the motion of Earth around the sun. Let's talk about something real quick. Let's go to the day. One of the most basic things we've got. How long is a day? You can say 24 hours. Okay? And I'm going to say, that's interesting. What defines a day? You say from noon to noon. Well, before there was a clock, how did we decide this is going to be one day? You say, well, the sun's up there and then the sun's up there. Okay, maybe. Or is it based on the Earth turning once around, 360 degrees? Let's be real specific. Let's get way into the details here. I want to show you something interesting. Sun, big old S, Superman sun here. All right. Not to scale here. Earth. And we're going to put something right there. And Earth, we're overhead. This is an overhead view. So North Pole is right here, sticking out, coming right at you like that. That's the North Pole. So the Earth is going to turn this way as it's going around the sun. So the next day, when Earth is turned 360 degrees, it's just like that, right? That's 360 degrees. So this thing, this whatever marker I've got, it's going to face that way. Earth is turned 360 degrees, but I want to look at something. The sun is directly overhead. That's not facing the sun. If I want to face the sun, because the Earth moved, I actually have to wait 4 more minutes for the sun to be directly overhead because the Earth moved around the sun. This goes all the way around, takes 365 days, right? This takes 24 hours. So I've exaggerated all these things, but the difference between here and here is 4 minutes. So which one's a day? They both are. That's weird to say. They're both days. Which one are you used to? Clocks, everything is based on the solar day, from high noon to high noon, when the sun is directly overhead. That's here to here. So that is the solar day. This other one is called the sidereal. The sidereal day. And that's interesting. It means relative to the stars. Because if I took something that's not moving, if I took a star way out there, okay, not so compared to our Earth and the sun, nothing moved. The Earth turned 360 degrees. And that's a fact, and it's still facing that thing way off over there. So it did one full spin, and it's facing that thing again. So that's a day. But because we're worried about our sun, the way this spins, we're going to take the solar day, 4 minutes longer. Well, that's what we call 24 hours. So really the sidereal day is 4 minutes shorter. 3 minutes, 3.9 minutes, whatever. 4 minutes, right? There's a lot of detail when you get into astronomy. This is going to be fun. We're going to learn a lot. We've already got some vocabulary words from zenith and equinox and solstice, sidereal day, solar day. There's a lot to do. We've got a big project, a long-term project coming up. There's too much. I can't put all the details on here. It'll be just way too long. This is going to be a good unit. There's some stuff on Canvas. Check it out.